In this video, we are going to work on implicit differentiation. This is how you take the derivative of a function that is not solved for y. You take the derivative of every single term. If the term has a y in it, you must use the chain rule. For this term right here, x squared, that will be a power rule. The derivative of x squared is just 2x. We go to the next term. The derivative of y squared, that has to be a chain rule because there's a y in it. So the derivative of the outer is 2 times something to the first. The inner, as is y, and the derivative of the inner is y prime. So the derivative of y squared implicitly is 2y prime. Finally, we take the derivative of the term on the right side. The derivative of 25 is 0. Now your next step is get all the terms with a y prime in it on the left, all the terms without a y prime in it on the right. So we are simply going to subtract off 2x from both sides. On the left, we're still left with 2y prime. On the right, we're left with negative 2x. Now the final step to get y prime by itself, we just divide. We divide by 2y on both sides. Okay, the 2's cancel, the y's cancel. We're left with y prime on the left, and on the right, the 2's cancel. So our answer, y prime, is equal to negative x over y. Final best full credit answer. Number 2, for the first term, 3y squared, that is a chain rule because it is a y in it. So the derivative of 3y squared using the chain rule is 6y, y prime. Then the second term, that is also a chain rule because there's a y in it. So the 2 comes along for the ride. The derivative of y to the first using the chain rule is y prime. We keep going to the third term. That's a power rule. There's no y in that term. So the derivative of 2x squared using the power rule is 4x to the first. And then, of course, the derivative of 3, and that's also a power rule, is 0. All right, so now we have 2 terms with y prime in it. Those stay on the left. The 4x does not have a y prime in it, so we subtract that to bring it to the other side. So we subtract 4x from both sides. So we still have 6y, y prime on the left. We still have 2y prime on the left. And on the right, we have negative 4x. Now, whenever you have more than one term with a y prime in it, we want to factor out y prime. All right, so to factor out y prime, we put it in front, and we rewrite the binomial. To get this term, we divide the first term by y prime, our common factor. The y primes cancel, and we're left with 6y. If we divide the second term, 2y prime, by y prime, we're left with 2. And then the right side stays the same, negative 4x. Now, finally, to get y prime by itself, we simply divide. We divide both sides by 6y minus 2, so that that binomial cancels out, and we're left with y prime by itself. So, again, these cancel out. Here is my final best full credit answer. Number 3, when we take the derivative of the first term, we use the power rule because there's only an x in it. So the derivative of x cubed using the power rule is 3x squared. Then we keep going. The second term, we must use the chain rule because there's a y in it. So the derivative of the outer is 3 times something squared. The inner as is y, and the derivative of the inner is y prime. So the derivative of y cubed, implicitly using the chain rule, is 3y squared y prime. All right, now we go to the right side. This here is a product rule. All right, we are multiplying 2 separate functions together. So 6x is my first function, and y is my second function. So we need 1d2 plus 2d1. The first function as is 6x. The derivative of the second function, y, it has to be a chain rule. The derivative of y to the first implicitly is y prime. Then we come back with 2d1. The second function as is y, and the derivative of the first function, 6x, using the power rule, is just 6. So there you have it, 1 d2 plus 2d1. Now, let's just clean it up a little bit and make it a little bit neater. So 3x squared stays the same. I'm going to get rid of the parentheses here. 3y squared y prime. On the right, I have 6xy prime plus 6y. So just clean it up, make it neat. All right, now we have 4 terms. 1, 2, 3, 4. The terms with y prime in it have to be on the left, so I need to move this term over. So I'm going to subtract off negative 6xy prime, both sides, negative 6xy prime. And I need to move over this 3x squared to the right because this doesn't have a y prime in it. So I'm also going to subtract off a negative 3x squared from both sides. All right, so on the left, these cancel. I am left with a 3y squared y prime, this term, and I also have negative 6xy prime, minus 6xy prime. All right, on the right side, 6xy prime cancels. I still have a 6y, and I still have a negative 3x squared. Negative 3x squared, I'm going to put the x term first, plus 6y. Okay, so we've done it. All the terms with y prime in it are on the left. The terms without y prime in it are on the right. Now, because we have more than one term with a y prime in it, now we need to factor out y prime. All right, so we factor out y prime on the left. We put it out front, and we rewrite that binomial. So if I divide this first term by y prime, I'm left with 3y squared. And if I divide the second term y prime, I'm left with 6x. All right, so I did it. I factored out y prime. On the right, that just comes down. Negative 3x squared plus 6y. Now, the last step to get y prime by itself is I divide that by this whole binomial. And I must do it on both sides. 3y squared minus 6x, divide that on the left, and divide by that on the right. 3y squared minus 6x. Okay, these cancel out. I'm left with y prime, all by itself on the left. Here is my final best answer. Number 4, this is all one term on the left. That's 2 separate functions multiplied together. 4 cosine of x, our first function, times the sine of y, our second function. So we need a product rule here. Okay, so for 1d2 plus 2d1, the first function as is 4 cosine of x. So that is the first function. For the derivative of the second function, I need a chain rule here because there's a y in it. So the derivative of the outside function's sine is cosine. The inner function as is y, and the derivative of the inner is y prime. So that is 1d2. Now we come back with 2 and then d1. So the second function as is just the sine of y. And the derivative of the first function, well, the 4 comes along for the ride. And the derivative of the cosine, of course, is negative sine. All right, so there you have it. 1d2 plus 2d1. And the derivative of 1 over here on the right is just 0. All right, so now I'm going to clean up each term. There's really nothing to clean up right here. I'm just going to bring that down. 4 cosine of x. Oops, typo. 4 cosine of x, cosine of y, y prime. But this term, I'm going to put that negative out front, and I'm going to put the negative 4 out front. Get the coefficients to the front. So I have negative 4, I have a sine of x, and I have a sine of y. Okay, I have 2 terms. This term has a y prime in it. It stays on the left. This term doesn't have a y prime in it. I must move it over. Because it's negative, I'm going to add 4 sine of x, sine of y to both sides. Plus 4 sine of x, sine of y. Okay, so now on the left, I'm left with this term here. 4 cosine of x, cosine of y, y prime. And on the right, I just have positive for sine of x, sine of y. Now, lastly, to get y prime by itself, I just divide out. I divide by everything but the y prime. So I divide by 4 cosine of x, cosine of y. Both sides. 4 cosine of x, cosine of y. Cancels, cancels, cancels. I've got y prime by itself right here. And here, the 4's cancel. So my final best answer is the sine of x times the sine of y divided by the cosine of x times the cosine of y. All right, the next 4 problems are on the next video. Thanks, calculus.